My name is Ershaghi, and I'll be making this presentation about the training needs for decision-making in the management of smart oil fields. Before I start my presentation, I'd like to express my gratitude to the SBE Foundation for supporting these distinguished lecture series. I have been working as a director of a center at USC for 4 years on issues related to the technology and manpower training of smart oil field operations. Now, many of the oil field operators these days have heard these terminologies, which really has to do with how we combine the information technology and oil field technology, and is all categorized under the buzzwords such as the I field, the E field, the IE, intelligent energy, and the digital oil field of the future. And really, the evolution of these type of technologies is changing the face of the industry. And if you look at over the last 3 decades, how our industry has changed in terms of some critical technologies that have elevated its ability to be able to do better jobs in terms of technology, going anywhere from the directional holes to the horizontal holes. You can see right now we are in a new paradigm. And on this technology S-curve, the whole technology of the intelligent wells and the smart oil field is really what's changing the face of the industry. Now, obviously, this is not happening because the fact that we want to be up to date on the technology. There are business drivers to do that. Technology gaps exist that needs to be addressed. And at the same time, there's a sense of urgency. Unlike many of the technologies that have taken 30 years to become into operations, industry is very serious to get a hold of advancements as necessary to implement these smart oil field technologies, because of the fact that they are facing assets, especially in the deep water, that requires the implementation of these type of technologies, and they cannot wait. The focus of my talk is really the role that the universities and the professional societies such as SBE and the companies play in terms of preparing the manpower to be able to implement these type of technologies. And again, I should also mention that besides the business dimension of implementing these technologies, there's also another dimension, and that is the dimension of being able to do our operations safer and better from environmental protection measures. This whole concept started on the use of maximum contact wells, getting some inspiration from nature that how we can drain the soil with the roots of a tree. The idea was, why can't we drill multilateral wells so that we be able to drain the reservoir much more effectively? And the minute this kind of a discussion came into our industry, the question was, how are we going to monitor it? How are we going to control it? Now, how are we going to minimize the re-entry? Because it would be awfully expensive to do that. And this is really all led into where we are or where we are heading. Then the question is, why do we have to go in these application of these type of technologies? So what's the need for that? And I'd like to give you a little background that you can see where the technology needs come and where the manpower needs come from. There's tremendous demand on our industry as an energy industry to be able to provide a sustainable base as far as the production. At the same time, the expectations are that we do everything much more safely and environmentally friendly in the future. There's no doubt in anybody's mind that in the next 100 years, the fossil fuel will still continue playing an important role in the whole energy basket as far as providing the sources of global energy for us. And when you look at fossil fuels, I think the only way that we can sustain this kind of a reliance until we develop the alternatives is that we come up with some effective ways in terms of carbon management. Now, the task, therefore, is, as long as there is demand for the fossil fuel, in particular, we talk about oil and gas, as an industry, we have the responsibility, global responsibility, to be able to push what we call the peak oil production into the future. And that's a very difficult task to do. Let's figure out where the feedstock will come from. The feedstock, in terms of being able to push the peak into the future, will be to improve the economics, be able to use better technologies, and be able to use smarter operations and people with advanced training. The sources of oil and gas for the future would be obviously not forgetting about the mature fields that still have tons of oil left in them, and making sure that we can go ahead and we have the ability to explore in very hostile and harsh environments, such as very deep water, and at the same time being able to look at some resources that we've ignored in the past, such as the unconventional hydrocarbon resources, the gas shale, the tight sand, and the oil shale. Now, in order to be able to do that, obviously, as far as the mature oil fields are concerned, we need to have technologies that would allow us to reduce the decline from mature oil fields. And we also have to be able to come up with a methodology to invest in the use of smart technologies to be able to produce from some of the difficult resources. That really requires, in spite of the high prices of oil, that we still be able to improve the economics to the point that we will reduce the re-entry into the wells, because that's a very costly operation. We need to have engineers that I call them plug-and-play engineers, so not to be dependent too much on one person's experience, but be able to use any of the engineers who have the proper training to do the job. And at the same time, we're going to be facing a shortage of manpower, be able to do our operation with a lesser number of engineers. And all of that, of course, will require that we be able to use more collaborative type decision in terms of managing these type of assets. Now, our industry does not have a good track record. We are one of the few industries that in terms of efficiency, we've had a very poor track record. We have operated oil fields with recoveries of 15 to 30%, and that's not really acceptable. We have had poor preventive maintenance track record. And the worst track record you could imagine for our industry is the data management, where most of the time we spend more time in terms of finding data rather than using the data. And at the same time, our industry is notorious for using this, what we call a disconnected decision support system, where people with different types of expertise make decisions without really having the ability to collaborate with each other and in real time. Well, we need to catch up with other industries, such as the defense industry, such as the medical industry, such as the space industry. We'd be able to work together, we'd be able to bring the information together, we'd be able to make decisions where we have our eyes open and we have access to all of the data. Is that happening? To some extent it is, but we still have a long way to go. There are certain technology enablers that are making these things possible. Now, the smart hardware is part of it. Service companies are working on it. Many of the research labs are working on it. Some of the universities are working on it. But a very important part of that is also the soft part of it, which is called the information technologies, related mostly to the software application. Now, when you put all of that together, what's also essential is to be able to have people to know how to operate these smart wells and how to use those decision support systems. And that's really where the focus of my talk is going to be. Now, you can see now over the last 10 years, in our industry, you see new buzzwords, the smart oil fields, the smart wells, the real-time operation, fuzzy logic. These are the terminologies that average petroleum engineers or geological engineers don't understand, honestly, got training into that. Now, what that really means is that if you wanted to feel comfortable to implement these technologies and to be able to manage them, you got to give them the proper education. Now, there are incentives for this change management. The incentives obviously would be that we do that because we want to reduce human error. Human error can cost the industry a lot. As I said, we want to reduce re-entry. These technologies offer the possibility of minimizing re-entry into the wells, whether it's offshore or onshore. We can reduce operation costs significantly if we do these technology applications in an effective way. And then at the same time, we are bringing for the first time into the upstream something that has been done in the downstream, and that is the automation. And of course, it is a much more difficult environment because of the size of our operations. And you're talking about acres and acres and acres of land operation versus a refining operation, which might be a few acres only. More than important than anything else is the fact that the industry, the way it's operating right now, it has its experts all over the world. And the way we are operating is that you have to be able to take advantage of the brain of these people, no matter where they are located. Is that possible? Yes, it's becoming possible now. Now, the terminology that you also hear more and more these days is integration. Integration means let's not just focus on the fact that I'm a reservoir engineer, that you're a drilling engineer, and somebody else is a production engineer, somebody is a surface facilities engineer, and somebody is a transportation engineer. If you look at an asset in that definition, really everything is part of the assets. Every component of these things that you're looking at, the subsurface, the surface facility, transportation, all the way down to the refining, all the way down to the marketing, they're all connected to each other. One change in any of those components could affect the rest of the thing. A drop in oil prices could affect everything else we do. A drop in oil production could affect everything that's happening on the downstream side. So if you begin to look at the asset as an integrated, a combination of all of these components, you can begin to see how important it is to be able to have access to all data at all times by all people in the operation. Now, the upstream challenge, as I mentioned, compared to downstream, is the fact that how do we combine the information operation of these three major components, the subsurface, a wellbore, and the surface? And how do we bring that in coordination with transportation, the pipeline leaks, the pipeline safety operations? And how do we bring that to the processing of the marketing? So this cannot be done until we begin to think in the whole concept and a paradigm, what's called these days integrated oil and gas assets. The important issue as far as a business driver is reducing uncertainty. Look at what is uncertain about our operation. Of course, a major part of it is the behavior of the reservoir, because that's the part we really don't have much access to, except for some limited sampling we've done with the wells we drill. We really don't know how the reservoir is behaving. And that's the part that always stays an unknown. However, the advancements in technology are making it possible for us to have a better visualization of front movement, of what's happening down there. And I think the more and more we begin to use those basically tracking system and subsurface monitoring, the better our abilities increase in terms of managing the asset. The next thing is that no matter how you look at this integrated asset, you have to have access to all data at all times. You all know the methodology of talking to a reservoir engineer asking for some well logs, and it says that's the petrophysicist, talk to him, and talk to the petrophysicist, say talk to the production engineers. This type of operations cannot last any longer when we talk about this very complex field operation. So the question is that how can we make sure every engineer, every geologist, every technical person in the company has access to all data at all times? Notice I keep emphasizing that work. And then at the same time, making sure that we make a decision, we make it in a way that we have looked at every implication of that decision. So that in the background, we have to have the ability that our decisions and the consequence of those decisions are simulated in real time with the high-performance computing to be able to make that decision-making possible for us, and looking at all of the implication of that. So how do we going to do that? What we need is we have to bring, just comparing to what we do with the other industries, it's called in our industry these days immersive visualization. We have to be able to immerse ourselves into what the operations is. I think this pretty much is similar to what our kids play on the video games. They immerse themselves in that fighting between two characters to the point that sometimes they forget that who they are. They think they're part of a thing. Can we create an environment that the petroleum engineer geologist feels they're immersed in the data, no matter where they are? You don't have to be on an offshore platform to immerse yourself. You can be sitting in your office at some comfortable location. However, we create an environment that you feel the temperature, you feel the pressure, you feel the vibration, you can smell the burning compressor, and then you can make a decision at that distance. That's called immersive visualization. And at the same time, you want to make sure there's transparency about data. Everything that you need to have access to is available to you, no excuses. Now, in order to do that, again, we get to the point that you have to have a system that can support that environment. No matter how smart you are, how much training you've got, you got to have the machines to be able to provide that for you. That machinery by itself is a subject of different discussion, which is how do you build integrated asset models. I'm not going to go into that, but what I'm going to talk about is that how do we drive that machine? So first we have to prepare the people to drive those machines, because it's the same people who are going to build those machines. The information technology is now making it possible for us to visualize bypassed oil. It makes it possible for us to do our operation with minimal footprint on the environment. And this is all possible if we can bring, again, as I mentioned, the multidisciplinary collaboration. What is necessary, therefore, we have to combine for any of the assets that we want to implement these type of technologies, looking at the technical feasibility, looking at economic feasibility, environmental feasibility, and social feasibility. The social part is a very important part. People oppose any change in the type of a decision making that could affect their career. And this is the problem our industry faces today. What the industry needs to do, obviously, is to gradually encourage the elimination of silo-style thinking. Because in that process, the expectations are fuzzy. We most of the time make decisions without having access to all information. And sometimes we make decisions by elimination of some of the options that may not be clear to us. And of course, most of the time we make decisions that affects our particular domain of expertise without knowing what the impact is going to be in other components of that native asset. The industry and the service companies have been responsive to that with some very elementary. This is what you call generation zero of what's happening. And you can see, you can go to almost most major companies and some of the even mid-sized companies, you can see that they do have visualization rooms. They're making it possible for you to combine the seismic data, the reservoir data, the drilling data. But that's just part of it. That's a step one. In that, you can see the ability, how you can bring this information together and make it possible for you to see the track of the given well and optimize, for instance, the course of the well that you're drilling. So these viz rooms that are mushrooming everywhere, this is really the first step. Our current people who are working in the industry, as well as the new generation of people coming, to begin to accept these type of technologies and be able to innovate advances in this technology, be able to use it. Now, part of the problem, of course, is every time you bring a new technology, you have to deal with the matter of trust. How trustworthy is that new technology? How dependable this new approach is to solving problems. If you're a drilling engineer, how much can you depend on these technologies to make sure that you're doing a safe operation? In order to realize the complexity of the problem, our industry, while is struggling to implement this type of a mentality, is of course dealing with an aging workforce that have not been trained to use advanced technologies. That's part of the problem. Now, as many of the aging workforce retires, and you talk about the ones who are mid-career professionals, then you need to be able to train them. And in fact, training the mid-career professional is probably one of the toughest because they have an established way of thinking and doing operations, and it would be very hard to change them, except maybe a few of them who see the opportunity for survival is to join this bandwagon, otherwise they may not survive. On top of that, you have to realize the problem that our industry faces worldwide, and that is recruiting top talents. I'm in the business of academic training, and I know the attitude of high school graduates about looking at our industry versus other industries. Our industry does not have a good reputation these days, and partly because of the past practices. The image of oil industry is a well that's blowing out and messing the environment. Also, our industry has a reputation as a very low-tech industry. Now, but that's not so. Obviously, we have to do a better job in terms of demonstrating the importance and emphasis on safe operation in oil fields. And we also have to bring to the attention of the young talents potentially coming to our industry the changing nature of our industry and the heavy use of high-tech in our industry. Now, within the training that we have to send the young people, as well as the existing staff, we also have to realize that the industry is going through some major changes. I'm showing you here the past, present, and the future. Each of these dots could be an individual, it could be a decision center, a decision point. In the past, that's how it was. Each one of us, depending on our expertise, will offer some input. And some big guy in the middle will take all of that and digest it, some of it perfect, some of it imperfect information, make a decision. And we were happy that we did our job. And we went through that kind of a thing for years and years and years. Gradually, we changed to what you see at the present. And of course, the future. I'm happy to report that many companies are adopting the future already. So the future is here for many of the companies, while some of them are struggling. In the future type of thinking, you have a kind of a flat organization. The flat organization which might be hard for some people to digest, is that you, just like in hospital, at any time you depend, no matter who is on duty, that person is knowledgeable enough to handle the situation. We don't have the operation of oil and gas to be like that. You have to have such and such person there to do the job, and if that person is on vacation, you're in trouble. So how can we do this flat organization? And that's why I keep using that term, plug-and-play engineers. Our engineers have to have the basic knowledge and understanding and willingness to take advantage of this type of a change environment and be able to participate no matter where they are, who they are. Once you start training this type of engineers, then you get more and more closer to the flat organization. It does not mean anybody in that organization at any time can change the whole thing. This is mostly because of the access to the data. Everyone has to have access to all data at all times. Now, who makes the decision, that's a separate story. Just depends, of course, what the type of operation is going to be. Now, to go in that direction, you could see that any place you bring the discussion, there is opposition, and there are people who think that might be a positive thing to do. The people who are against this kind of a thing, they're worried about the cost, they're worried about job security, they're worried about the chances of failure, they're worried about disruption that this may create in operation. The people who are for it, they think this might improve productivity. It will, by creating quick access to data, this obviously make the operation much more efficient. And also, it would reduce this mundane work, 8 to 5, that whole, okay, it's time to go home, versus doing something exciting every day. And at the same time, obviously, when you bring more transparency to the entire operation, you're reducing the human error. So the management, the manpower, is attacking it at its hardcore, attacking the whole issue of isolation, how we have trained engineers. And we are responsible in academic environment as well. Within the companies, it has been the culture of interdepartmental disconnect. If you look at the organization chart of a major oil company, even today, you can get it from their website, you can see the disconnect. You have a hierarchical system that really don't think people from one department talk to the other, although they will be. But that kind of a disconnect, it brings a kind of a mentality that eliminates, that opportunity to have clearance and transparency into the operation. At the same time, it kind of discourages multidisciplinary participation, where you actually make a decision where you have input from all participants. I'm not saying this is not taking place. Many companies are adopting it, but it is not really catching on that fast. And bottom line, of course, is that making sure that the people who are part of the organization, they do have the core competencies to do that. Now, the case for that we have to push for it from the academic point of view and from training point of view or from a professional society point of view is that we've got to realize we're dealing with very, very complex operation that could impact the environment, that could impact the safety of our people, that could affect in the long term the productivity of our resources, and we just have to take it seriously. We have to realize that to manage such complex operations, we cannot expect miracles from one individual or a single discipline saying this company is a reservoir-dominated thinking, so reservoir engineers are the king, they make decisions. There's a lot more thing involved in that. And so we cannot also afford, especially with the nature of the international operation of the companies, to have a disconnected relationship among the experts all over the world. So the collaboration becomes a necessity. No matter whether you're working on a global scale or even a local scale, even within a particular country, you have to have your experts to be communicating with each other. No matter what kind of a domain expertise you have, production, development, transportation, they need to be able to work together within an environment. Now, of course, that environment has to be created by the operating companies. If you don't give them the tools, they're not going to operate like that. Now, to do the manpower training for that, now these days, people use different terminologies. I call it hybrid petroleum engineers. Again, when I say petroleum engineer, I don't necessarily mean somebody with a degree in petroleum engineering. Our industry is notorious for hiring people from all disciplines. But I just use the term petroleum engineers, meaning people who work for petroleum companies. We need hybrid petroleum engineers. Some people call them Renaissance petroleum engineers. And all it really means is that these are the people who, in addition to the core competency courses or training, or on-the-job training, they also are familiar fully with the capabilities that information technology can bring to their discipline. And they have been trained, and they understand that how they can come up with new solutions. They can understand how they can develop the fault detection system. They can come up with ways that can operate the whole operation with using more tools that allows collaborative thinking. And also, it makes it possible for them to use their innovative skills to come with decisions in a kind of a non-traditional ways. What are the requirements in the training needs or skill needs of the hybrid petroleum engineers? Obviously, we need to have engineers who are very well versed in information technologies. Now, we need to make sure that they know how to define the problem and a solution at a very high level. And we want to make sure that they've been trained. You can't expect them. You can't just graduate them from schools or short courses and send them to a thing. Now you're going to go to this room and operate together. You have to actually create the same kind of internship that are used in many professions. In the medical schools, you don't operate on a patient unless you've gone through 3 or 4 years of training. In a law school, the same way. But petroleum engineering and many other engineering disciplines are very unique. You get out of a college and you're given responsibility to log a well, to drill a well. So you may not have been in an environment to understand how you work with each other. So you have to give them that opportunity to be trained in a collaborative environment. Now, in this setup, obviously universities have a role, the operating companies have a role, service companies have a role, and the professional society have a role. Now, have we played our role? Well, gradually. And the Society of Petroleum Engineers is catching on this subject. As you can see, more and more sessions and conferences are set up to address the question of the smart oil field operations and the training needs. And many of the major operating companies are catching on the subjects. Universities, unfortunately, most of them are not yet, because, again, within the universities, you have the disconnect. You have an absolute disconnect in many universities between, say, the petroleum engineering, the geology, and the information technology departments. You look at the SPE right now, we talk about the core competency for petroleum engineering. These are the topics listed. If your academic training is such that the students go through this type of training, that is the petroleum engineers. There is nowhere in the competency requirement they talk about the fact that we also want that it's to be trained in soft computing skills or this or that, and the schools don't have the facilities to train the students in that kind of environment. So there is that disconnect right there. And this is going to affect us for generations to come. So really the purpose I'm trying to emphasize here, if we realize there is a need to provide that kind of a training, it has to start from the school, it has to be supported by the companies, it has to be supported by service companies, and it has to be implemented soon. We don't have much time to delay this process. The hybrid curriculum that is gradually building up, in some places, not in every school, is that teaching the students to work with hybrid environments, basically, the virtual environments. Virtual environment is that actually some schools are working on that you create an environment where you have this default system, a gas condensate reservoir or a gas shale reservoir, and the student is given the question, just like a flight simulator. Given this condition, how would you make decision? And at that time, it's not thinking about my expertise in well testing or my expertise in reservoir engineering. You have to be able to combine the whole thing together. So rather than making mistakes in an actual field operation, you're doing it with this actual flight simulator or oil field simulator. This is what's evolving right now. And then at the same time, you have to understand how you visualize huge sets of data. We have to discourage our engineers spending 80% of their time working on Excel type worksheet to develop their own macros. That's not what you're hiring petroleum engineers. You have to make sure they have the access to all kinds of data and get away from the Excel hell and be able to use the data rather than manipulating the data. And of course, at the same time, we have to teach the new generation how they have to work with integrated asset modeling. And integrated asset modeling is not reservoir simulation, is not wellbore simulation, is not surface facility simulation. It's all of it together. That's what you call integrated asset modeling. At the same time, realizing that you want these people to go out there and collaborate in a decision support system internationally, globally, you also have to create an opportunity for them to solve certain problems during the academic years with students from other universities, from other places, coming up with problems or type of the decisions that faculty will collaborate. Students will learn from each other. How could you solve a problem over the internet? We have fantastic facilities for collaboration these days that the schools are not really taking advantage of. And then also making sure that when we talk about decision support, the students understand the implication of the decision. In other words, you have to create these simulators where the students or the staff, when they go through training, if they make a decision, the consequence of the decision is demonstrated on the screen, and they know, well, this is what would have happened if you have made that decision. So they understand how to solve the problem under pressure. Creating a pressured environment is very important, because that's exactly how you face this thing in reality. Such a training will require data management, immersive visualization training, work process definition. Most of the thing we do is in our head. Industry is beginning to catch on about how we translate work processes in algorithms that 90% of it could be done by the computer. And you, as a decision maker, look at the consequences and you make a selection. We have to teach people how to work with remote operations and control. We have to bring more and more education about the sensors and the sensor networks and what they will do for them. And because that will create a sense of dependency and a sense of support, and would eliminate the skepticism about the use of this kind of remote operations. Obviously, the goal, therefore, for building this type of a training would be not only focusing on a core competency, but we also have to make sure that we teach them how to make decisions under intense condition. In fact, creating exactly the oilfield situation. Creating, in fact, the situation that you got to make a decision in 5 minutes given all of this information. And at the same time, making sure that things get tough, you still, just like hospitals, just the same model. Things get tough, you still have the ability to go and talk to some experts and immediately get some solution for what you're doing. In the case of the oil companies, their participation really these days is boiling down to identifying a few champions. If you cannot identify a few champions within your companies who are going to take the ownership of this type of a manpower change, it's not going to happen. Now, many companies are successful in doing that. And then the next question is that how do you train the experienced engineers? And then emphasizing with these engineers or changing your reward system so people know that they're rewarded for the teamwork and not individual work for that matter. And at the same time, teaching the staff not to make decisions unless they've been able to work with all data, which of course means you provided for them a data access system that they really can do that. And of course, at the same time, the whole idea of eliminating the deterministic type decision, coming up with the decisions that has some risk associated with that, and understanding the implication of that, it's very important training. So the first step is that to create a physical environment, virtual classroom, whether it's for the universities or for the companies, to be able to people work together, be able to create these decision support centers. And this is not just a visualization room. It is something that you're actually able to communicate with people all over the world. And at the same time, making sure that as you put people in this environment, they begin to work together and realizing the boundaries that exist and how we can remove that boundaries that has to do with the cultural issues, language issues, the reliability issue, educational background. That's what goes back to the same question that I was trying to address in the form of what we call a plug-and-play engineers. No matter where you got your training, if you're certified as an engineer working for this very important industry, you have to be able to work with each other no matter where you come from. Step two is that we have to expand the comfort zone of communication. Currently, the best we've done is through emails and maybe some written communication. That has to expand to other forms of communication. I should be able, on my iPod or on my basically personal note, to communicate visually with everybody. And this technology is there, but to what extent is used in the petroleum industry, we have a way to go for that purpose, basically. And we want to make sure that as far as working on solving the problems, we teach people that how they can work on kind of a common intellectual effort, bringing all of the expertise they have. And at the same time, as I mentioned, making sure that we have learned how to work with people who may not be 100% connected with that. So to summarize, there is obviously a need as our industry is changing and is beginning to realize the importance of collaborative decision making, that both for the professional society, SPE, the universities and companies, to first of all augment the basic necessities that are needed for the petroleum engineering education, to bring to the attention of the students the additional training they need, to at least be familiar. We're not trying to train petroleum engineers to write computer programs, but we want to show them how other industries are using information technology. And we are asking them to implement their innovative capabilities to bring this to our industry. And we want to make sure that we change the classroom environment, at least to some extent. So a capstone course is no longer sufficient. We have to have for universities, and hopefully that the companies will support that, because they would be benefiting from that, training rooms that will allow students from various universities to collaborate with each other, to learn how to make decisions in a collaborative environment. Thank you very much.